Hi. Jerry Hamilton.
I thought you were talking about the young man. I thought you were talking about me. Of course, compared to you two guys. Well, you're my age.
Well, I don't know that. I could be older than you. All right. I'm sorry.
One to that thing that
Yes.
that's how organized I am.
Oh, that's right. I remember you mentioning something from there. Okay.
I did my residency at downstate New York, and
Okay.
Last week,
Thank you,
2 weeks ago, I guess it was, we had Middle East rapprochement. He was hitting an Israeli fellow, came back, see about getting a job here, and these guys got to meet.
Well, that's nice.
Yeah.
Yeah, that's fantastic.
It's better if the world could do it.
Yes.
Let's not go
We'll
there.
be there.
That's politics, not medicine.
I've often gotten in trouble with politics
Yes,
from
you
this
have.
lectern.
Yes, you have.
It's actually okay.
It's recorded for all time. Oh, did I get recorded what I
You were
just
the one.
said? Probably. Now you're in trouble.
Better.
What day is today, Terry? 24th.
24th.
Then back to Woodby?
I was there last weekend, briefly, just to kind of clean up, every weekend. Of course, with all those trees out there, it's a mess.
Oh, yeah.
With
The
the wind
windstorm.
blowing. Took a new chest of drawers, that kind of stuff.
We're doing two
Kind
today
of
because,
maintain.
did a lot more food
You
than
missed last week. I heard you were traveling.
Well,
Right?
I thought, yeah, I'm going to show you where I was. It's a quiz especially for you.
All right, we'll see you.
All right.
I just knew you weren't here, or what you're the mainstay.
Who kicked things off, Drew?
Yeah.
I got you right.
Yeah, I can give some to you too.
Good morning.
Well, look who's here.
Great to
Boy,
The world's greatest allergist.
Yeah, he is amazing.
parking is getting kind of interesting again. He is.
Oh,
I
okay.
get them early.
I thought you took the bus. There you go.
Just say,
That's
without their
Good morning.
Dr. Krause?
How are you, sir?
I'm all right. Still putting one foot in front of the other.
That's all that matters. Keep moving.
What are we doing here?
You need a signature in both.
Yes,
Both of them. Oh my
Yeah,
gosh.
we're overfeeding today. So,
Overfeeding.
thank you.
Yeah, we can pick up your lunch today.
Yeah, really.
Good morning. How are you?
Lovely.
Yeah, so everything
I've never heard anybody describe that before that way.
It's either lovely or
It's a lovely day today. And
Fair
whatever
enough.
you've got to do.
You get it.
Yeah.
You've got a lovely day to do it, that's true.
That I don't understand.
Although there was an accident on I-5 right at the exit, coming I-5 north to come down here.
I had north, okay.
Yeah,
And you said right at the exit?
it's about maybe
So
100 yards in front of the exit. So,
Left-hand lane?
yeah, so people are having to go around. Yeah, I mean,
I know, it's ridiculous. The good thing is I live here, so I'm always in the opposite direction of the
Gotcha.
flow. And I love it. I just love it. The only place I get into trouble is around Everett, when Boeing's letting people off.
yeah.
Yeah.
Well, the North Gate to downtown, you get a little.
Oh, I get right off at North Gate and then come through.
Oh, do you?
Okay,
yeah.
Yeah, because I live in Magnolia, so.
Oh, yeah.
he can't say.
Get to 15th and I'm home safe.
So, I'm
Three
assuming
cars, one of them
so.
looked pretty
Pretty bad.
banged up. No, this one, I think everybody's fine, but it did some damage to one of them.
Gotta find one sentence.
So, Christy, you can call me.
I know, well, actually, today, we both did it.
Okay.
So, we're good.
Okay.
Shire's representing strong.
You can call me anytime and say, dude.
Charge?
I appreciate it.
I don't spend
No
2
worries.
hours a day on the computer.
You don't. You should. It's the new age.
You never went EMR, did you?
What's that?
You never went EMR?
No, I'm not.
That's what I mean.
Yeah.
I'm going to go down to my list.
You were away last week, Dr. Waldman. Where were you?
I'm going to show you.
Okay.
Yes, you did.
There you go.
I heard you had a party for retirement. You did tell me that.
Yeah, I came, I came, I saw your grandkids.
Oh.
They had a great time.
Hello again?
Yeah, I'll bet.
Oh, yeah.
Oh, Braden, with our golden, he just crawls all over. And Peyton just sits there and puts up with it. It's amazing. Then he'll roll over his back and he'll be right on top of his belly. And then he makes it like a chair. He gets, where Peyton's laying down with his stomach to his side. And he goes in backwards and sits on his lap. He is, and Braden is a very active kid. He's a handful. He's a workout. He's so busy. Yeah. We went to a pumpkin patch this week. Yeah, they had fun. But you can see him, his hands are up in the air for balance. He's still learning to walk. On this uneven surface, it was one falls, go about 3 steps, next fall. It doesn't seem to bother him. It goes to the ground. Yeah, that's right. You going back east to see your grandchild soon?
I just spoke to her yesterday. They moved again from Boston to Westport, Connecticut. Hopefully it'll be the last move. I think he's really happy with this job. They told me they just bought a piece of property, tear down house, design a house. Really with us now.
Is he with the same company?
No,
Interestingly,
story.
we still haven't had all the repercussions of our takeover yet. So it just keeps going. So, just living a dream. What can I say?
Like yesterday, sometimes there will be residency stuff. But it's not that
Have a lot of independence.
on Thursdays.
I forgot, is Westport on the water? It must be a port, right? Westport port.
Good question.
I think it's different
I
residents.
don't remember it from when living back east.
Well, it's about an hour out of New York. I think you can take the train into the city.
Well, he doesn't work on the city, does he?
No, he works out there,
Yeah.
but a lot of people do. I haven't been there in the longest time. My uncle, they used to live there.
Sign it up.
They had this beautiful house, and I was a city kid.
More suburban.
Yeah.
No, when I met Wendy, she lived in New Canaan. Her dad worked in the city, but, community, but that's about 50 miles, I'm guessing.
Further out in the
But it was a nice suburban. You had to have at least 2 acre lots.
David, why'd you get up early this morning?
I'm on time for
Got to shave once in a while.
I do need to. I'll be out with it.
How are you?
I'm good, thank you. Good to see you. Good to see you.
Down
Doing okay,
there,
right on.
I gotta figure out
My
how to
shaking.
You moved since you got back?
Yeah. I had her.
Oh, you did?
I'm
the house
talking
around.
All right.
I have one girl.
Yeah, oh yeah, yeah. There's a little pop up there. It's great to make some really beautiful.
Yeah.
It's real good. How you doing?
The kind of things I usually do, I don't do any real science like this.
That was one reason we were able to.
I was going to review vitamin D and where it's really therapeutic value. Everybody jumps on the bandwagon. You're one of them. Although, they have to use this study, so it is a value, at least on meta-analysis in asthma.
I think compared to other phrases, vitamin C, E, this one you seem to hold up.
Well, it's not no, it seems like a marker for disease, but on the other hand, those diseases where it's low and you treat them with vitamin D, usually it doesn't make any difference. Now, on asthma, it does seem to be a difference, which surprised me because I thought, it's going to be just like the others. It's not going to be a value, but meta-analysis does support Anyhow,
So you get ready for parents?
well, I looked at that, but my problem is I don't know how to download from the internet articles, some of these articles, I'll get through that.
Oh, you did?
So it's basically, yeah, IL-7 receptor or like.
Yeah.
The reason why there will be some T cells.
She does have the worst
Complete panic aphasia.
So anything.
Oh, it's fine. Okay. Oh, yeah. Well, you know what, you're right, I still got it for
Yeah.
I fly this time, but it's only
But I think there are only like 2 better. It's like so.
So they did open up new lanes on the bridge.
Yeah, that's what
Yeah.
I got about 3 sections.
A year ago, still a bottle.
Yeah, it's much better. You're right, it's a problem. What a difference. Although
I'm trying to figure out what.
I'm driving home in the evening. You come out 5:20?
Yeah, I see all those people trying to.
It'll
Be a committee where they lose losing money.
You going?
You're also going to college.
Are you right?
Is it open?
Say again? I think so.
No, not going to be happy.
Did you talk to any of the
Tomorrow. He was gonna fly here, but then he changed his mind. Some conference. So, no, and I appreciate the connection.
Yesterday? So is
Well, the schedule an hour, I don't think we'll have an hour.
Appreciate it.
well negotiations at 5 or 6
Oh, I see.
No, but like I said, thanks for doing
Yeah, you guys have the like once.
I know, but I said like this day is busy there. It was walking.
I'll try to follow up.
Definitely
Not a surprise.
There's snow on Stevens Pass.
It's a little bit, but it's been raining too.
Yeah.
So, they won't open until another month.
How about the pass?
I was thinking of you. I was thinking
You
of
got
you
it,
guys already gone.
but you know, then.
Hey, you're here. Because you don't see Christina, she's on maternity. That's right. And we only see each other. Yeah.
Minus 10,000.
I want to see myself. Where are you living? I'm in Northampton for days a week, and then different channels. Yeah. Started a number of Everett. Yeah. But it's nice to split. You live closer than most people. Yeah. Yeah. Imagine that.
No.
Archie's
I gotta go to Orlando for the wedding.
Have you been there? No, I haven't. It's awesome. It's good. That mind is out. That's great.
No, if Drew is taking it,
That was probably. That's insane. You're moving.
Yeah, that's right.
Not far from Grand Junction,
he's got 1.5.
Colorado. Good time. Yeah, it was just a surgery night.
Yeah.
That's great.
No.
Yeah, exactly.
You're right, the best ages are, I found, for when it's, when you are age 55 and 57.
Yeah.
No, in other words, it's fun to go by yourself.
That is.
I know, I had a Phoenix in class, it took me 3 days.
Well, that's clinic last year.
Then we went on a Disney cruise, same time, that same week.
Oh, boy.
Let's go ahead and get started. This is why this has been called Journal Club all these years. It used to be a review of journals. It's only doing journals 3 or 4 times a year. I wasn't here last week. I know I missed a very good session. This is where I was last week. This is a quiz mostly for Gary, who loves these kind of things. Does anybody know what that is?
It's a river.
Yes. That's a good guess. This is a river that starts in northern Minnesota, which is where I was last week. It's another story why I was in northern Minnesota. A very famous American river.
Mississippi.
Starts in northern Minnesota, makes its way all the way to the Gulf of Mexico.
That's right.
Wow.
These are the headwaters of the Mississippi River. Anybody know where it starts?
Minnesota.
Lake Athabasca or something? Athabasca or something?
Well, not quite close. Lake Itasca.
Itasca.
It's really amazing to think you can walk over the Mississippi River at this location. It took like 200 years for people to find it. The Native Americans led the explorers finally to find the beginning of this. It's just a beautiful spot. It was a beautiful day up there. So I thought I'd share that with you. We got 3 speakers today, so everybody's got about 20 minutes, and usually go through a lot of information. Anybody want to go first? Frank? Got some coffee in your mouth?
That's right. That's critical.
The word of the day is journals.
I ended up putting kind of 3 journal articles together. We'll see how the timing goes in reference to the other 2 speakers. As it relates to today's talks, really no relevant disclosures. So the first study is a study primarily out of the Australia group, and this is actually an extension of a prior study from about 3 years ago, and we'll talk about that in a second. And really the background for doing this study is there really weren't any great long-term outcome data after going through peanut OIT. Most of it was very short-term. And obviously it would be, I think, useful to see if after initial therapy, to what degree is sustained unresponsiveness actually achieved and in what percentage of patients. Based on a sort of in tandem study by Brian Vickery and others, including Wesley Burks, they, at the completion of about a 3-year study of peanut immunotherapy orally, re-challenged patients with no further peanut. I believe these patients were all on daily peanut at about 2 grams, which is similar to this study. And then after 3 years of therapy, were not allowed to have peanut for a month and were re-challenged. And half of these patients passed the challenge. But beyond that, there really wasn't any reports of, if you tell patients to ad lib or perhaps keep it in their diet once or twice a week, what happens 6 months later or a year later? Do these patients lose the tolerance? What happens? And there just hasn't been a lot of data. So the other background in this study, and this has been an increasing theme of kind of the holy grail here, is how can we make peanut desensitization or tolerance more permanent? And so it was observed that Lactobacillus species can induce Treg, T1 cytokines, and IL-10 and I've put the references here, which you can check out if you'd like, that back that up. And so the theory here would be, let's do traditional OIT, getting up to 2 grams a day, but also add this probiotic with the thought that it might have an adjuvant effect in creating not just tolerance, but more sustained immunoresponsiveness. So this is referencing the initial primary study, which was completed roughly in 2013-ish, of 62 peanut children, and I'll show you the demographics in a second. The way this worked is patients were started on microgram levels on day 1, and then there was a rapid every 30 minutes, essentially doubling of that until you got to milligram levels, and then a sort of standard updosing every couple weeks. In other words, a milligram daily for 2 weeks, then 2 milligrams daily for 2 weeks, etc., until you get up to 2 grams a day, with the addition of the probiotic. They used maltodextrin as the placebo, interestingly enough, with brown food coloring to make people think they were getting peanut, I guess, and once daily treatment for 18 months. And then at the end of 18 months, underwent double-blind placebo-controlled challenges to assess for desensitization. If that was negative, it was repeated again, and I'm not sure why they weren't more consistent on the time period, but anywhere from 2 to 6 weeks later, if the patients also passed that challenge, they were told to continue peanut ad lib, really without any specific recommendations, which was a little unfortunate, I thought, that they didn't perhaps have 3 arms of comparing their various ways to do it. But essentially we're told you can eat it as much and as often as you want, or as infrequently as you want. I put in yellow here, these were the results of the study. So essentially 82% of the patients who are on peanut plus the probiotic got to this stage versus 3.6% of the placebo patients. One caveat here, so essentially, as you'll see, that means 1 patient in the placebo group and 24 out of 28 patients in the treatment group. Now, one of the criticisms of the study, but we'll talk about some disclaimers later, is to get entry into the study, they did not actually challenge patients. They relied on essentially 95% positive predictive value data. In other words, based on this skin test or this specific IgE, it was less than 5% likely that this patient would actually pass a full peanut challenge. In other words, they were deemed to be peanut allergic. Now, obviously, I think the statistics caught up with them, probably with this 1 patient in the placebo group. But the sort of disclaimer was that the demographics were identical in the placebo and the treatment group, so that this would wash out. In other words, presumably there would be equal numbers of, small numbers of patients that actually weren't peanut allergic. The other thing in the ad lib portion here is they were not restricted from having, they couldn't have sort of over-the-counter, if you will, probiotics, but they were allowed to have yogurt. And just to put that in perspective, a single daily dose of lactobacillus used in the study would require eating 20 tubs of yogurt. So they deemed that it would be very unlikely that people would do that. So again, you can see here just briefly kind of how it all shook out. The initial study ending about 4 years ago, 62 randomized patients equally split, and fortuitously 3 on each side did not continue, leaving 28 potential patients to study in this long-term 4-year follow-up study. Again, equal numbers declined to participate, so we were left with 24 patients in each group. Now, one question you might have, of the 24 in each group, it turns out the 4 on the treatment side that elected not to continue were unmasked later, and they actually all had passed the challenge. It turns out that the one patient in the placebo group who did get all the way through and presumably may not have been peanut allergic actually did continue into the long-term study. So just a few, for those of you wanting to look at the demographics, you can see really remarkably similar, perhaps asthma overrepresented in the treatment group, but otherwise really quite similar. As far as ingestion of peanut in the prolonged study, you can see nearly 3/4 of the patients in the treatment group. By definition, only one patient in the placebo group, and that was the one who passed the 2 double-blind challenges to get into the long-term study. The rest, of course, failed and were told to restrict peanut. Interestingly enough, if you look at, and again, these people were told to eat as much and as often or as infrequently as desired, you can see that about half of the patients in the treatment group did ingest peanut 1 or several times a week. And the typical ingestion amount was 2 grams or greater, keeping in mind that 2 grams was what they had throughout the treatment study. The baseline data, for those of you who are interested, was remarkably similar in both groups. Before starting the treatment study, the average skin test was 17 millimeters in both groups. And you can see a reduction actually in both groups, perhaps self-selected for some of those that did not continue, but sort of in favor of decrease in the treatment group. Just a look at reactions, because I think this question might come up. You can see that the bulk of the reactions occurred after the first year in the observational study. Really remarkably similar demographics in the placebo group. These were all occurring in the bulk of the patients who were actually peanut sensitive. So perhaps more of a surprise was in the treatment group, and about 80% of these patients had passed both the challenges. The reaction rate was remarkably similar. Kind of a regrettable point here is they didn't look at, was there something unique about the treatment group patients who had reactions? In other words, are they the ones that stopped eating peanut? And they didn't actually give me that data. So another way to try to look at the potential positive effect of this treatment is looking at specific peanut IgE, and the results are kind of what you'd expect. Significant decrement in the treatment group, and then they also looked at IgG4 as a proxy for immune tolerance, and you can see the expected increase again in the treatment group, and then looking at this ratio, somewhat similar to what some people do with venom immunotherapy, for example, and you can see statistically significant improvement in favor of the treatment group. So here's the bottom line there. So these patients made it all the way through this observational study, and then they re-challenged at those who had ingested peanut and so forth 8 weeks later, and you can see about 60% in the treatment group and the one patient in the placebo group who presumably was not actually peanut allergic. And they are reporting this as a potential positive finding of patients who perhaps will have more permanent tolerance. So there are several ways to look at this. Again, so essentially none of the placebo-treated patients who were allergic to peanut at the end of the study, which was 27 out of 28, acquired the ability In other words, sort of the natural history, and we all know this, that very few patients outgrow peanut allergy. We talked about some of the limitations of the study. Unfortunately, kind of more than the expected drop-off, where only half of the patients, roughly, in both groups went on to really complete the full study. Again, the other sort of standard limitations, this is a small group, single center, and there were also not specific peanut alone groups or probiotic groups to be a little more rigorous. The strengths of the study are outlined here. It looks like this effect was very specific. In other words, peanut plus probiotic OIT did not modify responsiveness to other allergens. And again, we talked about one limitation that a lot of people have criticized, that you didn't challenge these people before entry to the study. So some literally food for thought. These are my thoughts of some future studies that I think might be perhaps even more helpful. Comparing peanut alone versus peanut plus the probiotic to see if there truly is a useful enhancement effect for variable periods of time. And then at the end of the study, a month out, if patients are indeed tolerant, these patients would go on to study B and actually have a more defined, actually continuing the dose in the study, but at varying intervals, so 3 times a week, weekly, etc., and then following up with a double-blind challenge in 36 months, not only at 8 weeks, but perhaps even farther out. And I think this would give you a better notion of really how successful this approach is in creating what I would call more unsustained immunoresponsiveness. In other words, I think that would be pretty exciting to see if 3 months after stopping this, patients would still have tolerance. So something to think about with ongoing studies.
Frank, without the other arm of the study, probiotic, can they really make any comment about the value of the probiotic in this study? I mean, it doesn't really answer their goal.
No, because this really isn't totally, like, for example, duplicated otherwise in another study. So I think their thought, the theory makes sense, but you're right, it's really unfortunate that they didn't, and I understand it was probably a challenge to get this many people, but it's probably unfortunate that they weren't able to do that.
You only got 3 minutes for the other 2 topics.
Okay, all right. Yeah, well, these are, I can do it. So very briefly, this is, what I'm quoting from is actually an editorial by Jonathan Spergel and another person who I don't know. But essentially the idea is new pathways here that might be suitable for treatment in atopic dermatitis, and you can see them listed here, and I'll just go through them quickly. The first is one of the major areas where substance P interacts, and this is true, just as an aside, also in the airway, we believe, for example, in response to certain viral infections, where substance P activates neurokinin pathways and also what are called MAS-related G protein-coupled receptors. And essentially, these receptors, importantly, also are in mast cells, and when activated, produce itch through nociception and proprioception nerves. And on the bottom, you'll see reference to a treatment pathway in mice. And so the potential is that this could be a useful topical treatment in people. It's an ester, so it's rapidly hydrolyzed, so it would not be practical as an oral medicine. The second pathway is an inhibitory pathway, and that's gamma-aminobutyric acid pathway, and some examples of agonists that therefore would be useful therapeutically. Just as an aside, we've talked about IL-31 before, as it might be blocked by dupilumab, which is IL-4 and IL-13 being upstream of IL-31. When IL-31 is expressed, substance P and GRP are increased, and interestingly enough, it also decreases expression of the inhibitory pathway. final pathway, I have no idea how they came up with this name. Transient receptor potential vanilloid receptors. Essentially, they're osmoreceptors. So one thought is that this is one of the major pathways where dry skin mediates itch. In other words, that becomes a hyperosmolar state. These receptors are triggered, leading to itch. So obviously, potential treatments down the road of blocking the, if you will, the agonist pathways and inhibiting the pathways, I should say activating the pathways that would cause inhibition. And we talked about dupilumab. So in 10 seconds, you need to memorize this graphic. This is just showing you where the receptors are, both in the dorsal root ganglia, but also in the skin directly. And that's, of course, the only place the osmoreceptors are. I'll let you look at that later. And then very briefly here, this literally was just published looking at the effect of Mepolizumab in preventing sinus surgery. The first thing to point out is much higher than the usual doses of 300 milligrams monthly. This was 750 IV monthly for 6 months. The primary outcome was, could we avoid surgery? This, in brief, is how they gauged the size of polyps. Rhinoscopy was used for that, not imaging. And then they also used a visual analog score with essentially a score of 10 being, I feel, just fantastic, and 0 feeling like I can't breathe at all. And so this was their sort of premise for the primary outcome. In other words, and unfortunately they worded this as a double negative. So no means, yeah, the patient probably still needs surgery. And I think this makes sense. In other words, if the polyps are still huge, they probably need surgery. And if it bothers the patient a lot with smaller polyps, they probably still need surgery. Again, just the demographics, and I'll kind of cut to the chase. Again, you can see that they were pretty evenly matched. If anything, the treatment group actually had slightly worse VAS scores. And this will show you the outcome. And the punchline, as you can see, if you look at the primary outcome, although there was a trend in favor of Mepolizumab, there's not statistical difference. And then if you look at the two separate things, you do get some statistical difference. But if you combine them together, you really don't. And these are just the individual symptom scores, all statistically, some borderline, but in favor of Mepolizumab. These are AEs, and I just highlighted something I thought was kind of interesting, that a couple of these patients had hematuria. I'm not sure what to make of that. And the treatment group. And so my take on this, and the authors, this is Klaus Bockert's group in Belgium, sort of hemmed and hawed a bit, but I think the place of this may be more, okay, you need surgery. Get the surgery over with and kind of have it rolling as they come out of the ER. So maybe in a preventative way, this will be much more effective as a systemic agent. All right,
We'll push on, Bill.
Press on.
Is it covered by insurance?
That's right.
And you're
Not yet.
Not yet.
I guess fortunately a lot of these patients, the asthma is bad enough. They could get it covered that way, but not for polyps alone.
It's surprising that some surgeons still just do polypectomies instead of enterectomies. I haven't figured out why they do that, other than
So
they
they
just
can
want
do
them in
another
the
one.
future.
Did I say that?
That's what they talked about last week.
But yeah, I was gone last week too. Went to southeast Utah, Monument Valley. Didn't have any consultant for a small startup company, but no impact on today's talk. Beautiful place, Arches National Park. Some journals I reviewed today are looking at TSLP and allergic disorders. Just as a brief review here, the TSLP is a IL-2 family cytokine interacts with these two receptors, primarily the TSLP receptor, and then on the target cells such as mast cells, basophils, monocyte macrophages, T cells, you also find signaling with IL-7R receptor, because you stack signaling with the first step in that is JAK kinase activation. It's why I'm focusing on these is now it's a new target for asthma and other allergic disorder therapies, because it's tricky where the action is, and it has these relevant actions on dendritic cells, T cells, mast cells. And this recent review just highlights that there's two different pathways of an allergens that interact with dendritic cells in the airway epithelium, leading to activation of T cells, the Th2 subset, and primarily down IL-4, IL-13, and then IL-5 pathways. And TSLP is one of the major epithelial cytokines released that launch that, very upstream versus targeting downstream cytokines. And similarly, when you have a non-allergic etiology such as pollutants or cigarette smoke, TSLP is also released, and this is where you get your innate lymphoid cells that are turned on. And these are primarily IL-5 and IL-13, no IL-4 in these situations. So it's a good target because it's hitting both allergic and non-allergic etiologies of asthma. So a couple really impressive articles coming out. This one was a Nature Communication where they looked at the in-depth 3D structure of the interaction of TSLP with its receptors. And the bottom line here is that TSLP is it's got 4 helical loops in it. So it's in blue. It's a positively charged cytokine. And it interacts at the site 1 of the TSLP receptor. It's only one part, and this part of the TSLP receptor's got a negative charge. So electrostatic charges bring the two together in the inflammatory site. And then that triggers a conformational change on the TSLP this side that then attracts by electrostatic forces the IL-7 receptor alpha. And because of that, these very complicated X-ray crystallography studies showed that then there's conformational changes in both the TSLP receptor and the IL-7 receptor, so that they come together. Guess I'm not okay. Finally, here, this site 3, so that the cytoplasmic tails of both of the receptors come together, and then they initiate the JAK signaling. The main take-home points here were that it's a very dynamic situation, and this coiled TSLP undergoes a variety of conformational changes that induces changes in the structure to bring these two guys together to cause the signal. And then they actually crystallize the thing, so it's pretty amazing to look at this whole complex, what are actually bombarding our target cells in the airways with the TSLP receptor here, TSLP in the center, and then the IL-7 receptor alpha forming this unit. So why I highlighted this article is that it gave the detailed action of the anti-TSLP monoclonal antibody that's being developed by Amgen. So I don't know how to pronounce it. It's, from my take on it, is this Tezepelumab, but anyone know a better pronunciation of that?
Works.
So we'll call it Tezi from now on. This is that on the upper right part, and this is an FAB fragment of the, it's an IgG2A monoclonal antibody against TSLP. And it turns out that the way it works is that the variable heavy chain interacts with this part of TSLP. No other parts of the antibody react with it. And the effect of that is that if you then look at this X-ray 3D structure again here, by blocking, it's hard with that arrow there, but so the variable heavy interacts with this part here. It doesn't, because of that, this thing stays rigid, so the IL-7 receptor alpha doesn't really interact well with that. It doesn't block the final cytoplasmic tail of these receptors, so you can get a little bit of signaling through the TSLP. And this cartoon nicely goes through the whole, recapitulates what's going on. I don't think there's ever been a study that's in depth of how a biologic works in this regard. So TSLP's got positive charge. It interacts with negative charges on the TSLP receptor, and then it activates these specific binding sites that brings IL-7 alpha in, and then you get your biologic effect. So the monoclonal antibody, through its variable heavy chain, just interacts with one part of TSLP to block that interaction. And they've actually, in this study, they were developing some different sort of protein fusion things that had active domains of the IL-7 receptor alpha and TSLP that were about 1,000-fold more potent than the monoclonal antibody. So it's a variety of new therapeutics that could emerge from this kind of study. So to launch into what this recent New England Journal article where they used the Thymic in patients with uncontrolled asthma. The study population were about 1,000 moderately to poorly controlled asthmatics on medium to high dose corticosteroids and LABAs. And there was 1,000 patients, about 4 study groups, a placebo group, and then low, medium dose, and high dose anti-TSLP monoclonal antibody in this group. And the primary outcome was looking at reduction of exacerbations in this study population. They had to have at least 2 severe asthma exacerbations in the prior year that required systemic corticosteroids or 1 hospitalization for asthma. And the bottom line is that the monoclonal antibody significantly reduced the asthma exacerbations in this population. And the other really interesting part of this study is that this was irrespective of eosinophil levels. So it was a wide range from low to high eosinophils in the population. There was no prior stratification looking like a high Th2 phenotype that some studies have used, such as the initial anti-IL-13 studies. So you can see whether blood eosinophils less than 250 or greater than 250, exhaled nitric oxide less than 24 or greater than 24, or irrespective of their Th2 status. This was defined as a high Th2 status was a IG of greater than 100 and EOs of greater than 140. And the flip side there, less than total IG of 100 and circulating EOs of less than 140 became that. So the different ones compared to the placebo group in gray, the low dose, and doesn't appear to be any dose response that I could detect in this study. They were all effective in regard to reducing the asthma exacerbations, which was the primary take-home point on the y-axis. So pretty unique data here with an upstream inhibitor of this epithelial-derived cytokine to knock out, significantly reduce asthma exacerbations irrespective of the underlying phenotype of the asthma population. And the other thing that was unique compared to some of the other biologics is that all of their biomarkers were reduced. Exhaled nitric oxide, you can see the 3 study groups in the lower part of the graph were all reduced compared to the placebo group. Circulating eosinophil levels, and also, surprisingly, total IG was reduced by this intervention. So, there were a couple of troubling serious adverse events in the population. Overall, there was no significant difference between placebo or the tezepelumab study groups, but there was one death in the low-dose anti-TSLP group. This patient was a 74-year-old woman who died about 2 months after her last dose. She completed the 1-year treatment. She had a progressive decrease in her neutrophils, platelets, and total white blood cells throughout the study. It was midway on. It never. I think the neutrophils got half of the normal predicted range by the end of the study. She developed a pneumonia at that point and died of a stroke during that hospitalization for pneumonia. And then the other patient, midway through the study, about 2 weeks after, I think it was like week 16 or so of the treatment, this was a one-year course of treatment, developed a viral infection a couple weeks after his dose, developed Guillain-Barré. Survived it. He was in the hospital 4 months.
When they had the one patient that the neutrophil count kept dropping, why would they not drop them out of the study?
I don't know. I don't understand. The patient was in Ukraine, and I don't know what was going on there. But it seems so. When you look at a 74-year-old woman with
oh wait, so.
I mean, presumably somebody deemed it wasn't related, but I don't know how you could do that.
The TSLP has been associated with the host defense, neutrophil killing of bacteria through interaction with the complement system. It's also got some mouse studies that showed it's effective as a cancer prevention. So, there may be some significant risk of targeting so high up in this. I don't know. What do you think, Teal?
Yeah, well, I think there's some. The one thing I was thinking about is that it's been shown it's involved in wound repair, like epithelial wound repair, the Alcavari study, at the very start of when TSLP was identified. So there's definitely, blocking it, especially maybe there's the right dose of blocking it. Maybe you need to block it a little bit, but not altogether. Might be beneficial. But yeah, TSLP has a number of potentially protective roles. The stuff that Adrian Koloponsky is working on with TSLP and mast cells suggests it might be protective in sepsis, bacterial infections. So, did they look at lung function? I haven't read this paper yet. We're doing this.
No, lung function wasn't part of the. Oh, yes, I'm sorry, I take it all back. They showed that the pre-bronchodilator FEV1 is a marker of improvement of kind of your baseline, and that was improved by about 100.1 ml, 0.1 liters, so 100 microliters. And the post-bronchodilator FEV1 was also significantly improved by this. So the FEV1 data was also impacted in a significant way by tezepelumab. They did also a variety of secondary measures, such as asthma control and asthma quality of life. It reduced about 2/3 of those kind of questionnaire reports of asthma symptom scores, but not all of them were significantly impacted in the studies. About 140 patients in each of the study groups.
Yeah, I was thinking like a lot of these, like TSLP and IL-33 as being, like once you're in that persistent phase of having asthma, targeting them might have some beneficial effects, might have some downsides, but these would be, potentially therapies that could be used at the onset of the disease, or, when you have that viral infection that triggers, asthma in kids, or, might be disease modifying, unlike, anything anything else that we have right now. So.
In fairness to Paul, we have to move on.
Sure, yeah, let me just show the
I won't take
slide of the,
You can have extra time. I won't take 20 minutes.
so the point here, the blood eosinophils are down FeNO, and I just want to point out there's an article in the New England Journal that accompanied one with the other biologics, and most of them, they've had differential effects. So the Mepolizumab, you get a small reduction in Fe, exhaled nitric oxide, but no reduction actually in circulating levels of free Ig. The anti-IL-5 therapies, Mepolizumab, Resoluzumab, and Benralizumab, they reduce circulating eosinophils but no change in exhaled nitric oxide. And in contrast, the anti-IL-4, anti-IL-13, you do reduce exhaled nitric oxide, but you get a temporary increase in eosinophils. So of the biologics to date, this is the first one to impact two different inflammatory pathways.
Are they going to continue to pursue this drug after those two disasters?
Yes.
Yeah.
I think
You could see it as an add-on, maybe. I mean, it's getting way ahead.
How are you going to convince people to be in that study?
Bill, how redundant are IL-33 and IL-25? I mean, they all seem to duplicate their effect. So,
well, I don't think it can be answered right now, but they there's monoclonals against IL-25 and IL-33, so those are
being studied as well.
Yeah, one's available in psoriasis, so was it anti-12, 25? So, yeah.
Okay.
Yeah, it will take some study to tease that out.
Well, I'm much lower level of intellectual function in that study, so I picked changes in mucus and a new diagnosis called hypersensitivity cough syndrome. There's two things to talk about. So to make this good. So I don't have any disclosures. When you look at asthma and we look at the people who crash and burn and end up in the emergency room, it's always interesting when you see these people die, they have mucus plugs and the airways are all filled with mucus, and yet there's not really very much that's been studied about the mucus itself in these kids. So there's two main mucin proteins. There's mucin 5AC and mucin 5B are the principal mucins that cause the real tenacious viscous mucus to be formed in the airway, and the composition of the mucus determines whether it's protective or dangerous depending on the circumstances. So they got 38 children, 13 with acute asthma, 15 with well-controlled stable asthma, and 10 controls. And then what they did is they measured concentrations of these two mucin proteins. So the MUC5AC concentrations were 7 micrograms per ml in the control group, 22.4 in the stable asthma group, and 44.7 in the acute asthma group. So it looked like as the asthma escalated in severity, that this MUC5AC mucin protein actually correlated with the severity of the asthma. The mucin 5B was less variable, and it actually had a higher concentration in the control group, and then it sort of disappeared as the asthma worsened. So they thought that the ratio of this mucin 5B and 5AC would be able to distinguish how severe an asthma attack might be and what the risk of subsequent intubation and airway occlusion would be. So these are 4 different graphs, and it's the one on the far left, this one, is total mucin in micrograms per mil. And they have the healthy group, then they have the healthy group, then you have the stable asthmatics, and you have the acute asthmatics. And if you look at the MUC5AC protein, you look that it goes up pretty significantly from healthy to acute asthma. Then if you look at the mucin 5B protein, it really didn't change much with the different stage of asthma. And then when you looked at the ratio, there was sort of the inverse of the second graph. And then they postulated that this ratio of MUC5B to MUC5AC could be a predictive number for severity of asthma, again, just based on the mucus proteins. And these were just, they weren't even necessarily induced. They could induce some of the kids, but a lot of them is just spontaneous mucus production that was the determining factor. So if you look at the changes, the MUC5B protein is present in 2 different glycoforms, and the charge of it, when it moves along a isoelectric gradient, is what determines these two. There's a low charge and a high charge form of the proteins. So the increase in the MUC5AC component it's the same charge all the way through, and then the MUC5V is the one that changed from a low charge, which means slow mobility through the gradient, and high charge. And then this, again, the ratio of these two proteins determines how gelatinous and how thick the mucus is in the airway and what the likeliness is that they're going to generate plugs. So these are the proteins that they give a structural framework to the mucus that protects the airway surface, but at the same time, they're the ones that are getting the kids in trouble, and it's a function of this ratio of these two different mucin proteins. The 5AC comes almost solely from goblet cells, and the 5B comes almost solely from submucosal cells in the airway. So they're coming from different places. But when you get the different configuration change of the 5B into this high and low electrostatic issues, the low problem is when you get the low speed electrophoretic mobility. That's the one that causes all the trouble. And the high speed is not related to subsequent side effects. So when you look at these and you look at the kids when they flare up and you just follow their mucus production, you can actually predict what correlates with FeNO, it correlates with spirometry, and it's just basically is another marker of activity of asthma. And maybe you've had more experience with this. Maybe Teal has actually measured mucus in asthmatics. I don't know if he has a comment there. But it seems like it's a very specific change. When the kid's asthma worsens, you get a different ratio of this MUC5AC to MUC5B. And the difference in charge is associated with basically clinical severity. So the high charge MUC5B glycoform, which just means, again, the one that moves fastest in the electrophoretic gradient, was present alone in 67% of the kids with stable asthma, but only 33% of the kids had both the high and low. And then if you look at the kids that are in acute asthma attacks, this arrow was just 80% had both, and then the low charge glycoforms are associated with the flare-ups of the disease. So these are just electrophoretic gradients again, and the different colors are, the blue is both variant forms of the MUC5B, and the pink is the 5AC. So it just shows you the correlation with stable asthma and then worsening asthma, and the ratio of these proteins changes in the airway. So the thought is that these come from inflammatory cells and the mediator products. They've been shown to change the ratio of 5B versus 5AC, and that controls essentially how much likelihood there is of the airway occluding and the airway becoming obstructed. And the neutrophil elastase can break down the mucins in this, but when you have active asthma degradation, there's less of the neutrophils present, and that ends up impeding the mucociliary clearance. So you end up having the airway obstruction. So if the mucus gets into the airway and the white cells can't degrade it, that's what ends up forming the plugs and gets these kids into trouble prior to intubation. So this is a graph that's almost unreadable, but essentially it looks at sputum eosinophils versus sputum neutrophils and the total amount of mucins. So if you look at the ones that are bolded, these are the ones that are statistically different. So if you have total mucin versus eosinophils is significantly correlated, then the mucus protein 5AC and the 5B, these are all associated with stable asthma. And then if you get the acute asthma attacks, those numbers are no longer statistically associated. You have this neutrophil number is the most correlating, and then this MUC5AC, which actually goes up pretty dramatically with each of these flare-ups. And then this is a table that just basically shows the control group versus the children with stable asthma and the things that are statistically different. So if you look at the number of kids that are atopic, they're pretty much the same between the stable group and the acute asthmatics. If you look at total white cells, they're the same. Sputum neutrophils, there's a big difference in the children with acute asthma versus the stable ones. Percent of neutrophils as a total lymphocytes, again, statistically. Sputum eosinophils, so the numbers you'd expect to be correlating with acute flares correlate with these protein components in the mucin. So that just was something I thought was interesting because we never talked about mucus. We all know that that's the end of airway, and that's what finally kills the kids is mucus plugs and swelling. But they've done studies in adults, and as far as I know, this is the only one they've done in kids. So it's interesting to know that the mucus component can make such a big difference. And I don't know, I've been taking people with refractory bronchiectasis and treating them with N-acetylcysteine to see if I can get them any better. And they hate the smell and the taste, but after reading this, I started trying some of the mucolytics and some of my more brittle recurring infection patients, and I don't know if I have any statistical data yet, but I'm trying that. So I had to ask Teal if he's looked at this.
Comment on that. First of all, we described the method for measuring mucin by ELISA actually back when I was a junior faculty member. But the thing that's important is MUC5AC is the one that's been described in Th2 high asthma. That ratio has been shown to be altered, although mostly at the gene expression level, because mucins are kind of hard to measure. But I think the key recent studies are that MUC5AC, if you knock it out in mouse models, it actually takes out airway hyperresponsiveness entirely. That's Chris Evans' paper. And so there's something that people don't really understand, that actually MUC5AC itself is regulating the development of airway hyperresponsiveness. And then MUC5B, which, like you say, is mostly in glands, is different. It's really involved in innate immunity. And so there's this association with developing pulmonary fibrosis with MUC5B polymorphisms that's been very prominent lately. And the thing there is that MUC5B binds to the cyclic class of receptors, which are on macrophages. And so it's thought that MUC5B is involved in innate immunity. And so MUC5B knockouts are susceptible to infection. This is very important. It's partly because they're hard to measure. It's something that people don't really understand. But I think it is more than just liquefying the mucus. I mean, people have tried to do that quite a bit and haven't really shown a great benefit, but there's a lot of mucolytics that are more effective and less toxic to the airways that are in development, like the guys at UNC. So, I mean, I think that's a possibility that that liquefying. I mean, the other thing was John Fahey's study showed that neutrophil elastase was essential during acute exacerbations for breaking down the mucus. So it's that thought that, like, especially during an acute exacerbation, you have a neutrophil influx that's essential. You don't want to actually block that. But that's great. I mean, I think that's an underappreciated area that should be. And the other thing about it is that, our studies showed that when you acutely challenge people with dry air hyperpnea, you get a marked increase in MUC5AC. And that actually is in association with the release of neuropeptide substance. You guys talked about substance P before, but actually in human airways is predominantly neurokinin A, not substance P. There's 3 receptors for that class of neurokinins, and those were released in association with leukotrienes in our study.
Well, obviously, Teal knows a lot more about this than I do, but it's something that we can actually adjust. And I actually tried to get the insurance company to let me try Pulmozyme in some of these people with just refractory asthma, and they said for $3,000 I could try it for each patient. So they weren't very interested in letting me get approval for trying Pulmozyme, but it was one of these off-the-wall requests. This patient's been in the hospital 6 times when I tried this, and they still said no. So.
Yeah, well, unfortunately, I haven't really, N-acetylcysteine and Pulmozyme and stuff like that. I mean, I have a few people that I've inherited that take that, but it's not ever been my impression that works so well. So,
my limited I have to agree with you with my study of 3. So. Yeah. The second is cough hypersensitivity syndrome, and I don't know how many of you see 2 or 3 chronic cough patients every day, but my life has sort of become cough. And it's either sinus infections or cough, and that seems to be all I ever see. So they're postulating a new diagnosis, which is cough hypersensitivity syndrome. So when you code these people with your ICD-10 coding, I tried to find out what the code number for this was, but the lady who was going to give me the answer couldn't find it, so I don't know if this is established at CMS yet or not. But most patients with cough have a heightened sensitivity to cough, so they have a persistent sense of the need to cough. So even innocuous stimuli cause triggers. So cold air, warm air, exercise, odors, chemicals. And this has now been officially labeled as this cough hypersensitivity syndrome. So when you look at cough, you have voluntary cough on one end of the spectrum, and basically there's not really a stimulus that you need for that. It's under conscious control, and the patients can actually control whether they cough or not. And then you get to the reflex cough, which is at the other end of the spectrum. There's a stimulus that needs to be done. People can't control the cough because it's reflexive. And then there's the two different kinds of cough. There's the irritant, sort of non-productive cough that bothers everybody. And then there's the protective cough that you don't want to knock out. So if you take out somebody's cough reflex in their airway, then they're going to get into more trouble. So developing antitussives has proven to be a lot more complicated because they don't want to just take out all cough. They want to take out the irritable cough and not the protective one. So if you look at the cough mechanism, they still really don't understand all the neural input that goes into cough. It's a coordinated effort of the respiratory muscles, but the neurophysiologic pathways are just still too complicated for anybody to have fine-tuned any different diagnostic pathways that we can use. And these cough hypersensitivity syndrome people, it's associated with multiple diseases. So it doesn't have to be an allergy or a viral infection or chemical sensitivity. It can literally come from almost any different source of insult to the airway. So this is the status of our understanding of the neuro pathways that induce cough. You have two ganglia in the airway. One is the nodose ganglia, and the other is the jugular ganglia. So they're basically in the upper airway beneath the brainstem, and they have two different pathways of innervation. And it's thought that this nodose pathway, which is the red one, intercepts in brain with the brainstem, and then it causes basically the involuntary cough. And then the jugular pathway is the one that seems to be associated with the voluntary cough. So reflex, there's a difference in split with the nerves, but they haven't really worked out which is which. And then the innervation goes back to the epithelium, and that's actually where the sensors are, and the effector mechanisms are in the central nervous system instead of the peripheral. So when you look at this, it's basically a notion that multiple underlying mechanisms and neural activation and sensitization cause the coughing. It's not one process. And since there's no animal models of cough that are any good, there's really very slow research in this because they have to use humans and they can't get an animal model that works. And they're really trying to target just this unproductive cough instead of the reflex cough. And that's proven to be quite elusive. So they're looking at peripheral sensitization of chemoreceptors and mechanoreceptors in the airway as actually the cause of this problem. And if you look at the biopsy of the airway, or BAL, you find that peripheral inflammation alters the activation threshold for cough. And it turns on the sensory fibers, and which transmitter is involved. There's still sort of arguments going which one is the most important, but there's 4 or 5 neurotransmitters involved. In animal models, what they can do is they can show that inflammatory mediators in the airway can change the nerve sensitization, and then it responds to allergens, viral, cigarette smoke, or pathologic insults. It changes with all those different insults, but it changes in different ways for each one, although the end result is still that you have a hypersensitive nerve. The mediators are prostanoids, leukotrienes, kinins, lipid mediators, neurotropins, protons, oxidant, and an ATP acting on their normal receptors, and yet all those mediators have been shown to induce this hypersensitivity cough syndrome. And the transient receptor potential, the TRP receptors, and the voltage-gated sodium channels seem to be the areas of most intense focus at this point. So again, another cartoon to try and make something complicated simple, which may have done the opposite, making something simple complicated. You have 5 receptors and 5 neurotransmitters that seem to be involved in this pathway. You have the neurokinin pathways, the TRP pathway, the ATP pathway, the sodium channels, and calcium channels. And then they all work, and the receptors in different places. So there's the central neurons in the cough pathway and the sensor, and then there's the peripheral neurons in the pathway. So the ATP receptors and the TRP receptors seem to be more active in the peripheral pathway, and the calcium channels and the neurokinin channels, and they seem to be more active in the central pathway. So they're trying to figure out, again, which pathways we can effectively block to give cough suppression without taking out the protective cough reflex. So the sodium channel blockers, there's 9 of them, and numbers 7, 8, and 9 seem to only be expressed in sensory C fibers. So these are the ones where the most interest is because they think that's where they can most affect the cough without taking out the protective cough, just the irritant cough. These seem to all work on sensory nerve excitability and are expressed on both nociceptor and mechanoreceptor neurons, and they're upregulated in everybody with chronic cough. The neurokinin agonists are looked at in human studies in BAL fluid with chronic cough, and it's elevated, but they don't know what that means. The neuromodulators gabapentin and amitriptyline have shown efficacy in chronic cough patients, but they're not sure how they work. And then the purine antagonists, the ones that work on the ATP receptors, it's some initial success there blocking cough, but it works in the absence of capsaicin, so they're not sure exactly what the mechanism is.
Yes.
So what this just basically is for me is that I've always struggled how to identify these chronic cough patients, because when you look at ICD-10, you put cough in and you have like 300 different causes of cough. And unfortunately, most people don't fall into any of those causes, so you have this chronic cough and you just have nothing else to put. So this cough hypersensitive syndrome, if I can actually get an ICD-10 code, I'll give you that so that you can put on your dictations, because none of the other ones seem to fit. But it's just, I see so many cough people and I have so little idea what to do with these people. It just seemed like this was something that maybe we could all, if we could code them together, we could maybe study them a little bit more effectively.
Yeah, that's.
Oh.
Well, thank you. We covered a lot of ground in 1 hour. Thanks for your insight, Gil. I know entirely too much about that.
Because we're like hardcore with the number of articles. Actually, we're doing this.
Hey, you know, on ICA, you know, it's the old label we had 100 years ago, and then it all went acid reflux and cough, and then of course that's fallen out of favor. Now it's back to the and you know what? I've been telling you what the answer is for the last 30 years. You have a hypersensitive.
I wonder how good do you think this is? Well,
but it's interesting is that that's
They
going to be
have IBS.
that was the same one that they
it's going to be
They're
accepted.
wired wrong,
Just
but
because it could
It's
be.
going to be accepted by.
Well, yeah, it has a whole set of rules.
And I listen to that, I do too. And you know, I do the whole workup and I do spirometry and all that. And you know, you work them out when you try stuff. It doesn't work.
And you're the 15th person that's working on it.
Yeah.
Well,
As long as you're not the next presenter.
I do too. It's what you have.
Try to stop the bucket. Hey, you got the total workup.
I'll look.
I'm
Let you know. I mean, I appreciate you telling me. I would
Although I haven't tried that. I saw you
not here.
It's
TSLP and Outline or they don't do anything. It's actually hang on pretty soon.
Yeah.
So maybe I should go back and try that.
I don't know, but we don't have a lot else to offer.
Yeah.
So it's just a frustrating group of people.
Yeah, so
Well, it's kind of like vasomotor rhinitis.
Exactly. Another one of those.
I get my excuse for failure.
Well,
I run a chapter
we're
on
trying to set it
Yeah.
up.
It's one of the best things I ever did.
And I
Basal
will
peritonitis, and I have a table that shows that none of the drugs work very well. And I give it to the patient, see it's in print, it's just not me that's failing. And so that's coming very good.
Yeah, it's always nice when you give them something to make them happy.
Yeah, well, I don't make them happy, I make it.
Yeah. Well, you're welcome. Gary, will you tell me what happened?
Hey,
what? Will you tell me what happened?
Yeah, too bad. I didn't know which one to talk about. More interesting to the group.
Yeah.
Really?
I knew I couldn't cover both.
Well, we didn't have him there initially. We wouldn't have been after.
Well, exactly.
But so they asked us for a dermatologist, analysis, and a pediatric.
Yeah, would you rather get electronic or?
So they asked us to put electronic. But if you do that with education.
phenotyping to
We'll get that up. Dr. Ortega, it's coming out.
Not very far away.
Thank you.
Is that gonna hold true for this one?
He's our fifth allergist. He just came from National Institute.
For an approval kind of process?
They started
You
in
got
the
approved?
Shoreline clinic, which we opened.
Yeah, it was, I mean, because it's very effective in a lot.
You didn't hear that from me. But we've never moved into an area where there was actually good medical care available. All of our other satellites are in these places.
On Thursday evening. Similar to this
So
one.
now they put it in Woodinville, you know, and that's Kirkland, they put it in Shoreline, which has.
It's our
Lens
Thursday
group is only
evening
2
journal
miles
club.
away,
We
so
used
they
to
don't
have
really
reps
need
there. I
any
think that they actually, our division.
Woodinville is at the medical center. It's in the, there's a group of Woodinville pediatrics. One of like 20 pediatrics.
Oh, okay, yeah.
Well, this is that same building.
Okay.
So they remodeled the floor so that people could work there. And we have the derm folks and allergy and the site chiefs sort of right through that one.
Yeah,
It's a nice actually. It's really nice. I'm not sure he's aggressive enough to market himself.
Got one right after
We
we
had
had
a-
it.
Yeah, we had a big
I can
case
take
with
it's
that
not a
with
big-
CFTD, and he was on Spivriga. I haven't used that. You know, when you use all those drugs together, it's the same. Have you used this drug yet?
Well, moving into
I was
places
curious
with
because
allergies,
Gina had come up and said that you guys were interested.
Yeah.
The only reason I bring it up,
looking at
Dr.
about
Ortega's coming back out.
20%. And the primary care
End
people
of
are
November is the pool one program.
and the dermatologist is so the
And I did not know.
they
this was
go
something you
anywhere.
guys would
Can't
be
they get
interested
referrals?
in coming to?
They can, but it's just
I myself
not.
have been going.
I can take that.
Yeah, the doctor.
Of course.
Yeah,
They were-
they
Yeah,
can't
I'll take
extend
that.
it.
Oh, yeah, that's right, yeah.
That's the problem.
Did you see that
But
little
I've been
Hispanic
interested
guy
in, yeah, because I just said, okay.
with the workup at Children's?
Okay.
He comes in with 30% lung function, and then they worked him up at Children's over a month. Sent him out with 80% lung function. I was drifted back down to 30 or 40. And I asked you if you could see him, and you said yes. He's only like 17. Has he gotten through the system to you yet?
I don't think
He's,
I definitely haven't seen
he's 18 years old, a nice kid, just doesn't talk.
know.
And a dad who's like, watch out, she wants to get you. And a dad who does all the talking and wants to find out why is this kid doing nothing? Why does he sit around and not do anything?
Oh, okay.
And, you know,
I haven't, you know, part of the problem is that, I'm only attending one.
Things you do this much already.
I got a research funding, I have meetings like.
Tuesday, Wednesday?
You know, I'm actually back.
Yeah.
But go through our website.
Perfect.
You're screwed.
Yeah.
I'll make sure it's right.
I hope he doesn't pin his name. I did that at Children's,
No, yeah.
but they didn't give me an answer.
Perfect.
They just
So
said
then I followed
it's
up
better.
with that.
You know, that's all I got.
Thank you.
Yeah, they did this workup, but their responses, we don't know what he has, but he's better.
I see.
So,
it's
okay,
great.
what does that mean? It didn't help
Oh,
me.
okay.
It's frustrating, but I don't know if he's, you know, I thought about vocal cord dysfunction, but it doesn't fit the criteria for that. And he just comes in literally with 30% lung function, lung spirometry,
Yeah.
a normal
So, you know,
looking curve,
someday-
52 out of 96.
Well, you definitely should
But I
have
mean,
seen it
maybe we should
pulmonary,
think about it
so.
by-
That's why I thought you'd be the best person.
Yeah, so.
Anyway, well, I'm not in any hurry, I just wondered if you'd
Okay.
seen him yet.
I haven't seen him.
Yeah.
Yeah, I think you'll remember it.
Yeah.
Anyway,
That's right, yeah.
I'll appreciate whatever.
Isn't that a beautiful country?
Sure, I mean, he really does have that
Take
low
care.
lung function.
Oh, and Dr. McBride, I was just going to introduce myself. I'd never met you before. My name's Monica. I'm with GSK. I'm the Mepolizumab professor.
Oh, so we're trying to get somebody on that was at the U. And she's got 30% lung function, and she left, whatever she left here on that, had her on something, and then her insurance wouldn't pay for it. She was getting a compassionate release through UW. And now she's just on Xolair, and unfortunately her lung function has just continued to drop. She's not very allergic, so when she was on that because of nothing else.
Right.
Very nice. She's either Lebanese or Iraqi.
What was her EO count?
It was pretty low too. It was. I mean, there's nothing super bad, but her lungs. That's the only thing super bad.
You know, the thing with the U is, you know, they got their own parameters coming out of the pharmacy. So
Yeah.
it's difficult.
But when you go to our insurance, they say we're not going to cover this because they see how much it costs.
I know, but did you ask for a trial?
Well, see, so far right now, I asked Matt to see if they could put her back on it and then continue it when she comes up north because they have people at the U that just spend their whole day getting prior auths accomplished.
Oh, yeah,
They
absolutely.
don't have anybody to do that.
Yeah.
So I was hoping he's going to see her again, but her insurance is such